Now, how to solve this problem? We have initial velocity of the ball, final velocity of the ball, with the mass of the ball. We want to find out what's the impulse acting on the ball, which means we don't know what's the impulse yet. We only know the initial momentum, final momentum. So which means we can find out what's the change of momentum. Now, change of momentum gives us impulse from impulse momentum theorem. So the change of momentum is 20 kilogram meter per second. Now, impulse momentum theorem gives us impulse equals change of momentum, and it also equals force times t. So which means impulse is 20 kilogram meter per second. Now we want to find out what's the average force. We know impulse now, we know time, 0.01 second. So force is impulse over time, which will give you 2000 Newton. So that's the average force acting on the ball during this impulse. Now you can do the same thing if it's a two-dimensional change of momentum. You just need to find out what's the change of momentum in x direction and what's the change of momentum in y direction. And change of momentum in x direction give you force in x direction, impulse and force in x direction. Change of momentum in y direction give you change of impulse and force in y direction. Now, after the discussion, let's think about this special case. Why can we go cliff jumping? So it's relatively safe if you jump to a water which is 10 meters below you. But it's definitely not safe if it's not water. And why is that? We need to use impulse momentum theorem for this again. So impulse, which is change of momentum, equals force times time interval. Now if it is hard flow, now you throw an egg from hard flow. The egg would come to a stop immediately, so the time interval is very small. Very, very small when it's hard flow. Now, the velocity of the egg or momentum of the egg to the hard flow would be the same compared to if you throw egg to the water. So mv, those two mv, you throw them from the same building would be the same. But what's the difference is that the egg is come to an immediate stop on hard flow, but the egg in the water would go down. So it will increase the time for the egg to come to a complete stop. So that t would be larger for this one. But we know impulse, which equals to change of momentum, would be the same for this case and this case. So which means F here would be much smaller than F here. Then jump to the water. That's why it's relatively safe for you to jump to the water from a high place than jump to a hard floor. We have we have impulse momentum theorem. Change of momentum equals force times theta t. Now if you do it in differential, you have force should be differential of momentum over time. Okay. So what happened if f is 0? Apparently, if f is 0, the momentum is constant. We call this one conservation of linear momentum. So conservation of momentum comes from a condition that force is 0. For example, if you have binary ball system, 3 balls, okay? Now the white ball moving initially and bouncing into 3 ball. Now during this case, all the forces, when they collide, all the forces are between those 3 balls. The external force acting on those 3 balls are 0, so the momentum of the system is conserved. And we call this one conservation of momentum. And as we said, it will helpful for us to solve a lot of a problem. For example, you have 2 skaters. They are on the ice. One is heavier, one is lighter, and initially both of them are at rest. They push each other, so they will both have some velocity. Which one will have higher velocity? Which one have, okay, let's say higher speed. Which one has higher speed? Which one has lower speed? So let's say this problem, you have skater A 75 kg, skater B 50 kg. Initially, both of them are at rest to give each other a push. We don't know how large this force is, but we know after they push each other, skater A has velocity 4 meters per second. Can we find out the speed of skater B using the information here? And here we can use conservation of momentum. Initially, both of them are at rest. So what is the momentum of the system before they push each other? Think about it for like 10 seconds. Okay. Apparently, the initial momentum of the system is 0, right? Okay. And then after they push each other, what would be the momentum of the system after they push each other? The answer is also 0. The momentum of the system after they push each other is also 0. Because there's no external force doing work acting on them, not only doing work. So you have normal force, and it will cancel with gravity for each of them. So the net force on skater A is 0 in vertical direction. Net force in skater B is 0 on vertical direction. The only force on A is a push from B. The only force on B is a push from A. So the net force acting on the system is 0, so momentum should be conserved. Now using that information, we can write down an equation. MA VA plus MB VB equals 0. MV is MA 75, VA 4, MB 50. So you solve this equation, you'll find VB is negative 6 meters per second. If you choose velocity of A to be positive. Now it just means velocity of B is in the opposite direction of velocity of A. And you can do the same thing. And this is exactly why, if you ever go to a shooting range, that you should put your rifle on your shoulder. If you don't, the rifle could recoil very intense and hurt you on your shoulder. So let's see, a rifle shoot a bullet. The mass of the bullet is 5 grams. The mass of the rifle is 3 grams. And the velocity of the bullet is 300 meters per second. What will be the recoil velocity of the rifle? You see, when the rifle shoots a bullet, the net force acting on the bullet and the rifle is 0. External net force. The only force is between the rifle and the bullet. And that considered as internal force. It won't change the momentum of the system. Only net external force will change the momentum of the system. So you can build an equation. You will find the mrvr plus mbvp equals 0. If you plug in everything together, I think you will have VR equals 0.5 meter per second. And you don't want the rifle to hit you at 0.5 meter per second. Now, why if you put the rifle on your shoulder, the recoil velocity would be much smaller? Because in that case, it will be the mass of the rifle and the mass of you. V recoil plus MBVB equals 0. The mass of you is very large. If this one is very large, it will greatly decrease this recoil velocity. Okay, just remember momentum is a vector. So momentum conservation can happen in 2 dimensions. So if you have PA, PB, in this case, if you add PA and PB together, it's not 42. It's 18 in X in Y direction and is 24 in X direction. So that's why if you have 2-dimensional condition, you should have conservation of momentum in X and the conservation of momentum in Y. You should do them separately. So that's what we have learned today. In general, total moment impulse changes momentum of the system. This is Newton's second law. F equals dp dt, and impulse is defined as the integration of force over time. The impulse momentum theorem gives us total impulse equals change of momentum. Now, if the external net force is 0, then we have momentum conservation. We'll stop here and then we will come back for condition, which is application of momentum conservation.